15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, and thank you for joining us on Space Nuts, a show about astronomy and space science, and as my brother put on our sticker, stuff. So we talk about all of that, and today we'll be talking about gravitational wave detection because something big has happened. And Fred was at a conference to discuss this very discovery, so we will be getting it from the horse's mouth. Not that he's a horse, but, you know, if he was, he'd be a thoroughbred. We're also going to look at a problem with the SpaceX capsule because the toilet broke. See, this is what happens when you don't pay the rent. Anyway, we'll find out what they had to do about it. It wasn't pretty. It was not pretty. Involved spoons and all. No, we don't want to know. Space doogies everywhere. We'll also be answering questions about the Big Bang, sound in space. It's a theoretical question. And whether or not humans could live on the gas giant moons of Titan and Io. I don't think I'd like it very much, but could it happen? So we'll get into all of that. My name is Andrew Dunkley, of course, your host, and joining me as always is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. Good to see you again.
Good to see you too, sir. Now, a little bit of homework. We got a message because we were talking about radio telescopes last week and the 60th birthday of Parkes, and we talked about the first female radio telescope astronomer, but I think we left out radio telescope and referred to her as the world's first astronomer, which somebody picked us up on. So it was our glitch, just a slight glitch in the dialogue, but yes, we were speaking about a lady who was the first female radio telescope astronomer, correct?
The first female radio astronomer, that's right. Gosh, I always get her name wrong. Ruby Payne Scott.
You're having a week for it because I heard an interview you did on the radio last week with a colleague of mine on our radio station, and don't tell anybody that Fred forgot the name of his own book. Didn't hear it from me.
There was a good reason for it, actually, because Marnie was walking through the front door laden down with shopping bags and clearly needed help.
That'll do it.
And that diverted my attention from whatever the book's called.
Yeah, we'll mention. We might be able to mention that later.
Yes, we might.
But let's talk about this incredible discovery concerning gravitational waves. Now, gravitational waves are only a very recent discovery in astronomy, and we detected a certain number of them up until recently, and now, wham, bam, thank you, ma'am, they've just absolutely smashed it out and announced the discovery of 35 more from various sources. And you were involved in a conference about this only recently.
Yeah, yesterday, that's right. Although the conference wasn't about this work, it was actually about Chinese and Australian collaboration in astronomy. It's a very, very fruitful area with some marvellous Chinese astronomers who are involved with the research. And we had basically some update talks, and one of them was about gravitational waves. In fact, it was slightly different. The one which we were the talk I was at was about continuous gravitational waves. Now, by that they mean detecting things like the wobble of a neutron star as it rotates, because that would be a continuous process, rather than what's been detected so far, which are all the results of high-energy collisions between mostly neutron stars and black holes. So it was interesting, actually, Andrew. It harked back to a conversation you and I had probably a month ago or 2 months ago about mountains on neutron stars, which are less than a millimeter high. And the fact is that a mountain even that small could possibly produce gravitational waves, because it's as the thing rotates, it's not a perfect sphere. It deviates from a perfect sphere, and so there's an acceleration there. And the trick is to look for these continuous gravitational waves being emitted from those, which haven't yet been detected. But in the talk, it was given by actually one of the Australian participants in the. I think it's part of the OzGrav collaboration, which is Australia's contribution to this work on gravitational waves. And so he did mention the announcement a couple of days ago about exactly what you've said, that in the latest run of LIGO, and some of the other, one of the other gravitational wave detectors around the world, which is Virgo in Italy, that has netted, as you said, a further 35 new detections of gravitational waves. But the milestone I thought was worth celebrating is that, given that the first one was discovered in 2015, it brings the total now to 90 detections. Most of them are created by merging black holes, but there are also the possibility of neutron stars colliding, that's actually been detected, and neutron stars being gobbled up by black holes, which has also been detected. So it's really the science of gravitational wave astronomy has matured really quickly to have 90 of those events. And what highlighted it for me was 2 years ago, I published Cosmic Chronicles, a user's guide to the universe, which everywhere else in the world but Australasia is called Exploding Stars and Invisible Planets. And I know some of our listeners have seen that. But I had a chapter in that on gravitational wave detections. And I think at that time, I should have checked back in the book, but I think there were 10 altogether. Now, 2 years later, and we've got to 90. It's fantastic to see all this, and we're learning about the different sorts of objects that are providing these collisions. Something I mentioned to you in the email as well that staggered me. So when I read the report about this announcement that there's a total of 90 been discovered, I looked at the original paper, the research paper that is actually releasing this data, and the first 10 pages are lists of authors and their affiliations. I didn't count them, but it would be several thousand, I think.
Wow. We've talked about this before. The scientific papers usually have multiple authors, but when we say multiple authors, we're talking hundreds and some, as you said just then, possibly thousands at times.
Yeah, it's extraordinary.
Incredible. All those trees suffering just so you can get your name put down. The one thing that I noticed in this revelation of these 35 new gravitational waves that have been discovered is they can account for most of them, but one has a mysterious origin.
Well, yes. The problem is that, we've got physics tells us how big black holes should be and how big neutron stars should be, but the observations tell a slightly different story. And there are some of these that are really quite mysterious. I'm not sure which one you're thinking of, Andrew, because
I don't either.
There's at least one that's generated a black hole whose mass is 145 times more than the sun, and that means that the two black holes that contributed to this were both very big, and possibly bigger than might be expected from what are called stellar mass black holes, ones that are created by the collapse of the core of a dying star.
I'm just going to stop you there. Can you hear that? That's Fredo, our resident frog.
Okay.
He's a green tree frog, and he's taken. I think he's taken residence in our water tank, which is just outside my window.
Fantastic!
And we've got storms around at the moment, so he's getting very excited. So if we get interrupted by thunderclaps or Fredo the frog, that's why. So sorry.
Very good.
Please actually, I might just make a point. Of these 35 from the report I've read, 32 were caused by two black holes merging. 2 were likely caused by a neutron star. hitting a black hole, smashing into a black hole, and then they're saying one was unknown.
Yes, that's right, and you can kind of imagine that because what they do is they analyze the waveform of the gravitational wave as it goes by, and that you can tease out what's actually happening there. I think the way I read it was rather than unknown, I read it as ambiguous.
Okay. Which could have been one or the other.
Yeah. So in particular, it's one that's basically an object, a black hole, 24 times the mass of the sun, something lighter than that with a mass of 2.83 times the mass of the sun. Now, the ambiguous bit is that object with 2.83 solar masses a black hole or a neutron star? And that's the mystery. It's because the limit on neutron stars is less than 2.83 solar masses. I can't remember what it is. It's about 2, I think. And so, to get a neutron star that size is a mystery. I think that's probably what you're referring to.
Yeah,
because
so.
Something that size should collapse to a black hole.
Yeah.
But the feeling is that it's actually a neutron star.
Maybe it was on its way to doing that when it got...
maybe so. Maybe, got gobbled up at the critical moment.
Someone will probably think of this question, so I'll preempt it. Why is something so small as a neutron star creating such significant gravitational waves? Is it because of the density, the high amount of gravitational pressure existing in that body, and when it hits a black hole, kaboom?
Yeah, yes, that's right. It's neutron stars are they are extreme gravitational objects because their diameter is 10 kilometers or something like that. And it's that sort of gravitational well that stirs up the gravitational waves, if I can put it that way. So what I guess another way of putting it is that if it was a black hole gobbling up a 2.83 solar mass normal star, then you wouldn't get the same gravitational energy being released because... I think I'm kind of making this up as I go along, Andrew. But
it's space nuts. That's what we do.
Well, that's what we do. Yeah. But I think it's all about how steep the gravitational well is, and in other words, how compact this gravitational source is, if I can put it that way. Thinking of gravity as a stream of gravitons, which we don't know whether is the case yet, but it might be the way it goes. So yeah, extraordinary stuff. Look, it's the physics is really quite amazing, and the fact that we can detect these things at all is staggering. Yeah. The sensitivity of the LIGO works. It's got 4-kilometer laser beams bouncing backwards and forwards between two mirrors, whose separation is measured to, I think it's about, if I remember rightly, about 1/50,000th of the, with an accuracy of about 1/50,000th of the diameter of a proton. It's crazy stuff. Yeah. Crazy stuff.
And one of those things that, once again, just gives you a headache because you can't get your head around it. Dumb question. Someone asked me to ask you. Why have gravitational waves become such an important thing to study?
Well, we've always known there would be. It's only that now we've hit the technological gateway that allows us to do that. The technology of gravitational wave detectors, which has been struggling along for 40 years, 50 years perhaps. In 2015, with Advanced LIGO as the name of the project, they actually managed to attain this sensitivity that I've just mentioned. It's all about how accurately and reliably you can measure the separation of these pairs of mirrors. And that is now possible in a way that it wasn't. When you think of, you've got to get rid of earth tremors and all of that sort of stuff as well to make the measurements. But now the technology, and I guess to some extent the computational technology that we have as well, has improved to the level where it's possible to detect them. And so we've now got this flood of events coming in. The detectors are constantly being improved in their sensitivity. And that's why people are talking about continuous wave gravitational waves, because it seems likely that we'll start to pick them up at some point down the track.
Yes, and just like exoplanets, which, we're only 25 years down the track and we know there's thousands of them at this stage.
That's right.
I suppose 20 years from now, we'll probably be in the same situation with gravitational waves.
Yes.
And hopefully we'll be able to learn a lot from them, which would answer some of the many mysteries of the universe.
Yeah,
who knows?
That's right.
Okay, we'll leave it there, but obviously there'll be a lot more to talk about in the future in regard to gravitational waves. This is Space Nuts with Andrew Dunkley and Professor Fred Watson. Time to take a bit of a break from the program to tell you about our sponsor, NordPass. Now, NordPass is a password manager. And, of course, these days you have passwords for everything. And I've got dozens of them. I'm sure you have too. And it can be really cumbersome and complicated. And how many times do you sit down and you get the password prompt and you go, oh, what is it again? Can't remember. You grab your notebook where you've got them all written down, which is not a safe thing to do. And, from time to time you have to change them and you've got to think of something and, you know where I'm coming from. Well, with NordPass, all of that is looked after, all of it. It's pain-free. I mean, it's really quite simple. You can upload all your passwords to this one piece of software. They are kept secure. They update as you need to change them. You don't even have to go into the software to change the password. If you change a password on a website or something you use on your computer, it will pop up and say, do you want me to change this password in NordPass? Yes, please. Away you go. It's done and you can forget about it. In fact, the way the whole system works is you don't have to remember any passwords at all except for one master password, the password to get into NordPass. So how easy is that? One password to cover all the passwords that you might need. They also have a password generator so that you can create very complex passwords that you don't ever need to remember because they'll remember it for you and no one will be able to hack you. One of the other things I like about NordPass is that they will give you alerts. They will tell you if your passwords are compromised or if you've got an issue with certain passwords, but they will also give you alerts about some of the stuff that's going on, some of the nasty surprises that are going on in the cyber world, some of the activities of hackers and people who are trying to steal your information and your money. Let's face it, that's what it comes down to in the end. So it's a really great product and I highly recommend it. I'm using it at the moment. I've been using it for a while now, and I really love the service. And it sort of just works in the background. You don't have to think about it. So look it up. And we've got a special URL where, as a Space Nuts listener, you get a special deal: 2 years plus 1 month free for the premium premium plan with NordPass. And the URL is nordpass.com/spacenuts. You can pop in there, read all about it, grab the deal at this incredibly low price. So nordpass.com/spacenuts for 2 years, a 2-year deal with 1 month thrown in free for a premium plan. I wish they had software to fix my tongue, but that's another story. nordpass.com/spacenuts. Now, back to the show.
Space Nuts.
Now, if you would like to become a patron, as I've said before, it's purely voluntary. There's a good reason to dip your toe into the water of becoming a patron at the moment because Patreon and Supercast, both services that we use, are offering 30-day free trials for premium access. So if you've been thinking about it but you're not sure, well, here's an opportunity to give it a go for 30 days, see if you like it, and go from there. But yes, that's through Patreon and Supercast. Now, I noticed a couple of things popping up on the Space Nuts podcast group on Facebook recently where some of our patrons received gifts in the mail, much to their surprise. Yes, we've introduced a reward system. I did tell you we were working on some concepts. We've finally nailed a few down. So people who stick with us for a few months on Patreon will receive Space Nuts stickers, and then after 6 months we'll probably send something else, and if you stick with us for 12 months, well, we'll give you Fred's Lamborghini. No, he actually drives a Tesla. But it's a fiat, isn't it? I don't know. But yes, there are presents involved in being a patron, and we're working on a similar concept with Supercast. So if you'd like to try it out, go to our website, spacenutspodcast.com, and click on the supporter tab and go from there. But like I say, it's not mandatory. We're not going to make you do it. It's purely voluntary. Now, Fred, to our next story, and that is of great concern to space travellers, and that is a broken toilet on the SpaceX capsule that was, visiting the International Space Station. This is a big concern. Space doogies are filling my brain. Actually, it's full of that all the time. But what happened?
Yes, it's a fault on the capsule. The SpaceX's Crew Dragon capsule has got a broken toilet. It's docked with the International Space Station at the moment, and this coming weekend, it's going to bring 4 astronauts back to Earth with an inoperative toilet, which was actually spotted back in September, but they haven't they haven't actually made any attempt to fix it. Apparently,
there aren't that many space plumbers around.
No, there aren't. That's absolutely right. It's a tube that has come unglued, and that sounds like bad news when it's connected to a toilet.
Why don't they take blue tack with them?
Well,
that stuff's amazing.
Yeah, all this is underneath the floorboards of the capsule, or at least the internal cladding. So there's there's a capsule sitting on the ground awaiting liftoff, which has had this problem fixed, but the one in orbit has a do not use sign on it. And so apparently there's no structural compromising of the spacecraft itself. It's going to be fine to bring the astronauts back to Earth despite the leak. But the astronauts themselves will have to wear what are being called absorbent undergarments.
Yes, well, they've got other names: diapers, nappies.
Yeah, that's right.
Crap catchers. They could be anything. There's an actual double whammy to this story, which I think is very, very concerning.
I'm sure you're about to say the same thing as what I am.
They've just grown their own chilies on the space station. They've ate them in tacos they made on board.
Exactly.
Now they've got to sit in this stuff
all
the way home.
Oh, no.
Oh, that's it could not be worse. I mean, that's just the worst timing ever.
So you're quite right. They've grown the first chili peppers in space, which the female astronaut, Megan MacArthur, she described as the fact that they've grown these chilies as a nice morale boost. But she goes on to say they have a nice spiciness,
all right.
nice spiciness to them, a little bit of a lingering burn. Oh, God. Anyway, they have 20 hours in the capsule without the toilet. So,
oh gosh, yeah,
they'll be fine.
But I don't think I could hold it for that long.
There was another comment she made. Yes, she described the situation as suboptimal.
Suboptimal.
Yes, but manageable. Suboptimal, but manageable. Anyway, we've had a good laugh at their expense. I hope they're safe and everything goes okay. I suspect, Andrew, bodily fluids are pretty well something that you just take for granted when you're in space, because it is such a different environment from what we're used to here on Earth.
I remember some years ago we had a NASA astronaut visiting Dubbo. He was part of a Rotary program, and he was touring Australia, and he came here and did some special appearances, and I got to interview him on the radio and take audience questions. What do you think the first question was?
How do you go to the toilet in space?
How do you go to the toilet?
Yes,
How
exactly.
yeah. I mean, it's vacuum packed, isn't it? I mean, you
Well,
can't just go like you do on Earth.
No, that's right. No, there's all sorts of things happen. They freeze dry it, actually.
Yeah.
And
Well, we saw that portrayed in the movie The Martian. It was freeze dried and put in little, aluminium packets or something.
okay,
But
yeah.
he
I don't remember that.
reconstituted it to grow his potato.
Yes.
Yeah. Of course, there is a plus side to all of this, Fred, and that is that if they need extra boost for decel, they can just turn the toilet on and all will be well.
I don't think so. I think they'll leave it well alone. It'll just have one of those signs that you occasionally see in shopping centres: toilet out of order.
Not occasionally. It's a very common problem. It just goes to show you the complexity of space travel, though, doesn't it? You've got so many things happening all the time, and it's probably a good thing that the only broken part is the toilet.
Yes,
You can go without that for a while.
Yeah, you can.
You can't go without your retro rockets and your boosters and your navigational systems and everything you need to re-enter the Earth's atmosphere or get out of it, for that matter. So, we take it for granted today, but it is really a complicated process to get off the ground, get up into space, dock with the International Space Station, swap everything out, grow chilies, and then get back to Earth and hope your nappy doesn't leak. It's really, really a complicated system, and I applaud them. I mean, we're sort of accelerating through a phase where space travel is going to become so very common that it will just be an everyday, mundane thing we don't even think about, like planes flying over. We don't even think about that anymore.
Aviation
the way it is
the great model for how space travel will be. I'm sure that's right.
Yeah. Well, we wish them well on re-entry and hope that everything stays intact. And all I'll say to them is, if you can hold it, hold it. 'Cause I don't like the idea of Red Hot Chili Peppers on re-entry.
Oh, dear me.
Does not do it for me at all.
Nope.
Okay.
Nope.
We will carry on. This is Space Nuts. Glad to have your company. Andrew Dunkley here with Professor Fred Watson.
3, 2, 1.
Space Nuts.
Thank you for joining us. And don't forget to join the Space Nuts podcast group on Facebook if you're into social media. It's a great place to meet like-minded people. Share your astronomical photos, ask each other questions. What's been happening lately is someone will pose a really complex question and open it for discussion. And what amazes me is just the amount of information that people provide. They're so very, very knowledgeable and intelligent. They leave me in the dust. So it is, there's one post I've looked at the other day. Someone's very cleverly taken photos of a moonrise or a moon set. I'm not sure which. It's a full moon. But the way they've lined up the pictures, you've got a man holding the moon and putting it in the trunk of his car. It's really good, very, very clever. So take a look at that. It's on Facebook, the Space Nuts podcast group. It's our own user-generated social media platform where you can all get together and meet each other and talk about astronomy and space science. So well worth getting involved. And, of course, there's an official Space Nuts Facebook page as well. So they're both available to you. Now, question without notice. Of course, the volcano has been continually erupting on La Palma, the island of La Palma. And somebody's posted a question, I think it came through one of our avenues, I can't remember which, asking if the observatory on La Palma has been threatened. I have not heard of any problems there, and it would be on top of another mountain, would it not?
It is, yeah. So there are basically two volcanoes on La Palma, and it is the northern one on which the observatory sits. It's a caldera called the Caldera di Taburiente, if I remember rightly. I'm pulling this from distant memories because it's a long time since I've been to La Palma. I used to go there a lot. But the observatory is in the northern side of the island. The volcano is not quite down deep in the far south of the island. It's not a terribly big island, actually. I guess 100 kilometers, something like that, maybe a bit more. But the volcano is more to the south, and it's sort of it's erupting. The lava flows that are erupting are basically heading to the sea, to the ocean. There has been a lot of ash, though, and I've seen pictures, of people's homes where they're digging out huge piles of really fine ash, and that would be more likely to be a showstopper for the observatory. You would want to shut down if this fine dust was blowing up in that direction. I think the prevailing wind is from the west, though. My recollection of working there, it's probably blowing the dust the other way. Although it actually, I have to say, something else. It's off the east coast of Africa, and periodically we used to get clouds of Sahara dust blowing off, towards the island, and that was another thing that made you shut down as well.
Yeah. Well, all right. Well, somebody asked the question, so it sounds like, if anything, just some inconvenience.
Yeah, I haven't seen any big notices about it at all.
No, me either. Okay, our first question, or our second question, as it turns out, comes from Daryl Parker, and Daryl's a patron, so thanks for your support, Daryl. I have a question about the speed of light and the early universe. Was the Big Bang faster than the speed of light? I ask this because the Big Bang expanded from nothing to the size of a galaxy in a very short space of time. So was the Big Bang expansion faster than the speed of light in the early universe?
Answer yes. Sorry, I've forgotten the listener's name. Was it Darren?
Daryl. Daryl from South Australia.
Yeah, Daryl's absolutely right. Sorry, Daryl. It's absolutely right that space expanded from being subatomic in size to the size of a galaxy in something like 10th to minus 30th of a second. It's just mind-boggling. It's what we call the inflation period, or the inflation epoch, because it inflated very rapidly. But so the question behind this is, why doesn't that defy Einstein's special theory of relativity, which says the speed of light is the ultimate speed limit?
And I'm sure someone would have asked that question.
Yeah. So it is the ultimate speed limit for things traveling through space. But we're talking here not about things traveling through space. We're talking about space itself.
Yeah.
And space can expand at whatever speed it likes. It's the fabric of space-time, whatever that means. It's a glib term that we use, but it's not that easy to get your head around. But the space itself expanded faster than the speed of light.
And continues to do so.
Yes, in the sense that there are horizons beyond which we cannot see, because the light from some of those distant galaxies will never actually reach us because the expansion's too fast. That most of what we call the observable universe isn't receding from us faster than the speed of light, which is why we can still see it.
No, I'm talking about the outer limits, I suppose.
Yeah, and you're talking there about limits that are beyond what we can't see anyway because of the cosmic microwave background radiation, which we do see. That's looking back 13.8 billion years.
Yeah. All right. So, Daryl, the answer is yes. And it happened in a fraction of a split second, basically, and all hell broke loose. Pretty much. Okay. Thanks for your question, and thanks for being a patron, Daryl. Let's go to our next question. This comes from Stephen. Hello, Fred and Andrew. I never listened to podcasts until I discovered Space Nuts. Set a low bar for you. Amazing show. You've reignited my passion for space, and I thank you. My question, hypothetically speaking, if sound could traverse through the vacuum of space, what would it sound like? What would we hear on Earth? Now, Fred's going to explain it, but sound can't travel through space. So this is a pure hypothetical question on the basis of what if, and we do love what if questions. So, yeah. Or I suppose it prompts another question. Why can't sound travel through space? Because it's a vacuum?
Yeah, that's right. There's no medium to transmit sound waves. Sound waves are compression waves. They rely on, you're having something to transmit the sound, whether it's the air or the fretboard of a guitar, the soundboard of a guitar or a cello, whatever it is, it's got to be transmitted through some medium. And when you bang a bar of steel, for example, it rings, resonates. That's because the sound's traveling backwards and forwards in it. So there's nothing to transmit the sound in space. There is, space is not completely empty. There's this sea of subatomic particles in it, which are very, very rarefied. Certainly in interstellar space, you're talking about 1 particle per cubic meter or something like that. So it's certainly a better vacuum than anything we could create artificially on Earth. And that just means there's no medium to transmit the waves. But I tried to imagine what would it be like if the universe, if space did have a high enough density of material that you could hear stuff coming from space, and the bottom line is we'd be deafened.
Yes.
And probably the loudest thing in our skies will be the sun, because of the nuclear processes taking place inside it and the huge convection currents and the flares and all of that sort of high energy stuff. That will be very noisy indeed. There is, usually when we talk about this, I refer to the fact that when the universe was young, its density was high enough that sound waves did move through it. And we can still see the effect of those in the cosmic microwave background radiation. So think of the Big Bang. We've got a universe that's, for the first 400,000 years of its life, it's glowing brilliantly, just because of the heat, the energy in it. So all of space is a brightly glowing fog, which you can't see through. It's opaque. That then clears, but just because of the phenomenon of look-back time, the fog has been cleared, but we can look back to see a wall of fog, which corresponds to a look-back time of again 13.8 billion years or so, that takes us to a time when the universe was still glowing brightly. It's in microwaves now because the light waves have been stretched into microwaves. But what we see when we look at that microwave background, and it's basically all over the sky, it's a sphere of radiation that surrounds us, which we can see using radio telescopes. It's got little sort of blips on it of higher and lower temperature, only 1 part in 100,000 higher and lower. They're tiny, tiny differences in temperature, but those are interpreted as being due to what are called baryonic acoustic oscillations, which means sound waves in the Big Bang itself, or in the aftermath of the Big Bang itself. The universe as it then was, and we can learn a lot by studying those sound waves.
Well, the Big Bang would have been allowed.
Pretty noisy, yeah. That's the nice thing about the, these baryonic acoustic oscillations. They're the bang of the Big Bang.
Yeah. I just suppose some people are thinking, well, hang on a minute, sound can't travel through space, but you can talk to each other. So what's that? But that's light. They're light waves, aren't they? Radio signals.
They're this electromagnetic waves, which are long wavelength light waves. Yeah.
But it sort of prompts me to recall something I read recently about how sound is different on different planets. And I think we recently discussed Mars because it's the centre of attention at the moment. If you were on Mars and tried to talk to each other, it would be very, very muffled compared to how we hear each other on Earth because of the thinness of the atmosphere. So I would imagine that your voice on other worlds would change accordingly.
Yeah. Indeed. And
you might have to adapt a new way of communicating because sometimes it might not be understandable. It's a strange phenomenon. We've adapted to this environment, so our voices and our sounds are what we consider normal, but go somewhere else, doesn't work. Doesn't work nearly as well.
Right. Yeah.
Okay, appreciate that question from you, Stephen. Now I've got to find the next one because it's here somewhere, and I think this is it. Yep, this is from someone named Bandicoot. I'm going to guess he's Australian. Hi, I've been listening to the podcast for a couple of weeks and wanted to join in with the questions. What are your thoughts on the Pac-Man theory, where the universe doesn't have an end, but instead loops back to the opposite point? I think we've talked about that before, but this question is another one I don't think we've really looked at much. How realistic is it for humans to live on the moons of gas giants such as Titan and Io? Love your show, and keep up the good work. Appreciate that. Thank you, Bandicoot. Well, we'll start with question one about the Pac-Man theory, the universe being never-ending and looping back on itself.
There are cosmologists who espouse that idea. I think that would probably describe Roger Penrose's model of the universe, which has black holes being created and then getting so big they detonate to form another Big Bang. It's kind of fairly speculative, a lot of that stuff. We really don't have the observations to support it. We've got the observations to support a single Big Bang, with no evidence yet for anything that might have been another one. And so it's a theory.
Yeah, well, the Pac-Man theory is probably a cross between an ongoing expansion and Gnab Gib. So you've got
that's right.
a loop effect instead. But I suppose popular theory is it's just an ongoing expanding sphere. Is that the way they're thinking of it?
Yes, that's right. Ever more rapidly, except it may not have an edge. So
yeah, we don't know. We don't know anything.
That's right.
beyond what we can see. So it could forever remain a mystery. I suppose they do computer modelling of all these things and try to come up with concepts, but in the end, it's all theory. How do you prove something you can't see that's so far away that we'll never ever be able to see it? It's frustrating. Must frustrate you, Fred.
Yes.
That's why you turned to writing children's books, I suppose.
Yes, whose name I've remembered.
Oh, what's it called?
So it's called Space Warp: Colliding Comets and Other Cosmic Catastrophes.
You're just making that up.
Yeah.
No, I think it's on the cover. You should try reading that.
Yeah. I don't have one here. So.
Oh, dear. Now, the second question from Bandicoot, how realistic is it for humans to live on the moons of Titan and Io, which are gas giant moons? So, we've talked about potentially living on Mars and terraforming Mars and living on the moon. Io, Titan?
Well, Io is a moon it's the innermost of the bright moons, of the big moons of Jupiter. Quite a sizable object, actually, bigger than our moon, if I remember rightly, or maybe just a little bit smaller. But it's a volcanic world. It doesn't have an atmosphere. I think what would be the killer for humans walking on Io, or Io as it's sometimes pronounced, is the radiation, because it's got this strong magnetic interaction with Jupiter, and Jupiter's magnetic field is many, many times greater than the Earth's. And so there are these radiation belts that are bombarding Io all the time. And I think it would be a very dangerous place to put humans. Titan, on the other hand, out beyond Jupiter, Titan's a moon of Saturn, has interesting parallels with the Earth. It's a smaller object, although it's bigger than the planet Mercury. It has an atmosphere whose pressure is about 50% more than the Earth's. Right. And I've just actually looked up the speed of sound on Titan just to sort of check, the answer, comparing it with what we were just talking about. 194 meters per second, which is slower than it is on Earth. If I remember rightly, it's about 300 meters per second on Earth. That means, makes for an interesting world. It's got lower gravity but higher atmospheric pressure. Of course, the big killer on Titan is the surface temperature, which is about minus 190 degrees Celsius. And that's why you've got liquid natural gas on its surface rather than water. The water is frozen solid under your feet because that's what we think the surface of Titan is made of, frozen water ice. So once again, it's hard to imagine how you would put humans on a body like that for any length of time. I think, we know that robotic exploration is the way to go for these extreme environments. There is a robotic mission planned to go to Titan. It's called Dragonfly. It will be if I remember rightly, it's an octocopter, something a bit different from Ingenuity on Mars, but essentially a drone which will be autonomous and will explore Titan from a number of different vantage points. So that's something to look forward to.
That sounds exciting.
Yeah.
So scratch Titan, scratch EO. Maybe Mars, although you're not a fan of that idea.
Well, I don't mind. I'm a fan of the idea of humans exploring Mars, but what I'm not a fan of is the idea of millions of humans going to Mars to take it over as Earth 2.0, because that's not what it is.
Well, we did get another question this week about terraforming Mars, which we've talked about many times, creating an atmosphere, and it just wouldn't work, would it?
It leaks away because the planet's too small. That's right.
So you couldn't create enough atmosphere regularly enough to maintain it, even though it leaked away.
I think that's the bottom line. Mars is too small to hang on to an Earth-like atmosphere. Full stop. So you've got to find a source for replenishing it, and that's not an easy thing to do.
A giant space pipeline.
Yeah,
that would do it.
That would do it. But it's easier then to build your artificial world and have your disk world or halo world, like
domes or something, or underground.
Yeah,
who knows? All right, we bumped off quite a few questions this week, and thanks again, Bandicoot, for getting in touch, and thanks to whoever sent the question in about terraforming or creating an atmosphere on Mars, because I did read that and thought it fitted in nicely with that particular topic, so we got that one through as well. Don't forget, if you do have questions for us, visit our website, because that's where you can upload them via audio or through email, spacenutspodcast.com. You'll find the links. The AMA tab is where you can upload questions, or just press the button on the right-hand side of the page. And while you're there, don't forget to visit the Space Nuts shop. There's all sorts of things to buy. We've got over my left shoulder the Space Nuts sticker. Over my right shoulder there's the mug, and there's the tote bag. I'm not wearing the shirt today, but there's just so much that you can get at the Space Nuts shop, including this really crappy new book called Space Warp. No, it's terrific, and I've been getting a lot of feedback. Fred, one of my colleagues at the radio station, has a friend in Houston who's getting 2 copies for his nephews, I believe, or grandchildren. So, they're thrilled a bit. He actually got in touch with us to find out how to buy them. So he's going to grab 2 copies of Space Warp. So, you've probably sold 3 now by the sound of it. Yeah,
I believe so, yeah. I think it might be up as high as 8, actually.
Wow. Gosh, yeah. My very first book's only up to 7, so, it's a bit tough.
Yeah.
Oh, by the way, I didn't know whether to mention this or not, but my book, The Hitler Paradox, I got a scathing 1-star review the other day on Amazon. He was ruthless. So, I could take that personally, or I could just laugh it off. I will look into his complaints, is all I'll say. But everyone else has given me 4 and 5 stars. But he just found something that he didn't like and gave me an uppercut. So anyway, you got to. That's what you got to be able to take that in the publishing world, because not everyone agrees on literature. And I never profess to be the greatest writer in the world. In fact, I'm probably in the bottom 4%.
A number picked
start
up
somewhere.
Yes, exactly.
I'll just keep trying.
Keep trying.
All right.
That's what we all do.
Thank you, Fred. Always a pleasure. Nice to talk to you again.
And we'll speak soon.
We will.
Yeah, take care.
That's Professor Fred Watson, part of the team here at Space Nuts. And back to Hugh in the studio, who does whatever he damn well likes, but occasionally he actually does some work as well to put the show together and get it out on our various podcast platforms. Thanks for listening. I hope you can join us again next week. And from me, for now, Andrew Dunkley, it's bye-bye. See ya.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.